Hi all. Today we are going to discuss measurement of power and energy. In the outline of the power, we will see the what is power and power in DC and AC circuits and power measurements and power instrumentation. The energy, the what is energy, the energy instrumentation, energy meters and the single phase energy meters and three phase energy meter. These are the topics we will discuss in this lecture. So now we will see the power measurements, DC circuit and AC circuit. In the AC circuit, we have three phase AC systems and high frequency power measurements. The energy measurements you used to we are have the two topics: DC circuit energy measurement and AC circuit energy measurement. Example: power and energy measurement in motor drives. Next, concept of electric power. The power can be defined as the time rate of energy transfer or energy dissipation in a load. It is the definition of the power. Power is the rate of using or supplying energy. The rate at which work is done to maintain an electric current in a circuit is termed electric power. The electric power is measured in watts W. The SI unit of power is the watt, where watt is equal to I joules per second. The kilowatt is a commonly used unit where 1 kilowatt is equal to 1000 watts. For example, 2000 watts is equal to 2 kilowatt. So the electric power formula, normally the electric power is useful making the lamp light or a motor turn. The electric power equals the product of the current I and the potential difference V. So power equal to current into voltage V into I. Okay, that we know. So V into I is equal to current. P watts is equal to I into ampere, voltage into volts. So what is the power formula? P equal to V into I. So it is the one small module. If P is the positive, the component is absorbs the power. Where P is the negative, the component produces the power. Okay. Next we will see the power in DC circuit. The power in DC circuit is equal to the product of the voltage and current. Power is equal to current into voltage in DC circuit. When the system voltage is constant, ammeter readings are almost a sufficient indication of the power taken. The power is calculated by using voltmeter and ammeter or wattmeter. So P equal to I into V is equal to I square R equal to V square by R, where P equal to power in watts, I equal to current in amps, R equal to resistance in ohms, V equal to voltage in volts. So this is the one of the DC circuit, and this is also DC circuit. Here we only changed this position of the voltmeter and ammeter. We are always measuring the current in series of the circuit and voltage in parallel to the circuit. So the ammeter measures the current which flow into the voltmeter and load. Okay, same how much amount, the first diagram shows the ammeter measure the current which flow through into this voltmeter and load. Both current values are these ammeter measures. The voltmeter voltage drop across the ammeter in addition that of dropping across the load. Now in this diagram, this voltmeter reads the voltage drop between the load and across the ammeter. Okay. Next, digital wattmeter up to 100 kilohertz. The advantage: high resolution accuracy. Several techniques: multiplication of signals. Electronic multiplier is an analog system which gives us its output as a voltage proportional to the power. Indication required: A to D conversion. This is the digital instrument. So that A to D converter we are used in this multimeter. So next, Hall power meter. This is also one of the power measurement meters. Coil generates magnet that schematic wattmeter based Hall effect sensor is shown in the diagram. So the coil generates the magnetic field which is proportional to the load current. The sensor excitation current passes through Ri and it's proportional to the load voltage. Hall voltage is proportional to load power, problems, offset and linearity. So this is the one of the example for calculating power problems. How much power is used in a circuit which is 110 volt and has a current of 1.386 amps. The power formula is equal to P equal to V into I. Here ampere is there, voltage is there. So multiply that both, we have 150 watts. So this is the another example. The work done by a heater is 100 joules for time 4 seconds. Find out the electric power of the heater. Given the work done by heater is in watt. Joule is, we already know, joule is equal to watt. Equal to, joules per second is also called as watts. So watts equal to 100 joule. Time taken by a heater, T is equal to 4 seconds. Therefore the electric power of the heater by formula W divided by T, 100 divided by 4 is equal to 25 watt is it's absorbing. Okay. For 4 seconds it takes 25 watts. So next, the electric power of the electrical bulb is 50 watt. Then at how much time required to the electrical bulb to perform the work of 150 joules? So in this type of problems, we have electric power P equal to 50 watts or 50 joules per second. Work done by a bulb equal to W equal to 150 joules. We know that P equal to W by T. So here we know the P and W value. T only we does not know. So take the T outside. So equal to W divided by P is equal to time equal to 3 seconds. So now we have the time. So this is the some exercise problem you to solve. Label on the TV state 720 watt 120 voltage. Find the current supply to this TV. So here power P is equal to there, V also there, and we need only current IV only we need. So heater has 30 ohms resistor connected to voltage source 120 voltage. Find out the total power which changed to heat. So these two problem you practice in your own. Next, introduction to measurement of power. In a DC circuit, the power in DC circuit provided by P equal to V into I. Okay, the power can be calculated basically with the help of the just ammeter and voltmeter. The below diagram shows the circuit diagram for the measuring power in DC circuit. So this is the DC circuit, we already shown this diagram. Reading and ammeter reading. Okay. In single phase AC circuit, so the power in single phase AC circuit is provided by P equal to VI cos pi. So in AC circuit, for measurement of power, we are using the formula P equal to VI cos pi. Why we are adding here V cos pi? Because this is AC circuit. There is the power factor there in AC. That's why cos pi we added. Wattmeter is employed to calculate power in AC circuits. Wattmeter consists of two coils. One is current coil, one is potential coil PC. So the circuit diagram is displayed in the diagram below. Total power P is equal to wattmeter reading is equal to VI cos pi. From this diagram from this power factor can be measured as follows: cos pi equal to P divided by VI. Okay. Next, this is the three-phase AC circuit. This is the 1 wattmeter method. This is the 1 wattmeter connected in the across the load. Okay, single wattmeter method of power measurement in three-phase circuit. Okay, this is the three-phase circuit load connected across the load. For a balanced three-phase load, that is ZR, ZY and ZB, single wattmeter might be connected into any one phase as displayed in the above diagram. This wattmeter will find out the power in that phase only. Because the load is balanced, the entire power in the three-phase circuit will be calculated by total power equal to 3 into wattmeter reading, because this is three-phase supply. That's why we are adding here 3. So 2 wattmeter method we are using. The wattmeter 1, this is the wattmeter 2 shown in the diagram. This is the most general method for calculating power in three-phase 3-wire system, because it can be employed for both unbalanced load ZR not equal ZY not equal ZB and balanced load ZR equal to ZY equal to ZB connected in the either star delta. star connection or delta connection. The current coils are connected to any two of the lines and the voltage coils are connected to another line. The one with no current coil connection as displayed in the below diagram. Total power equal to wattmeter 1 plus wattmeter 2. So next we will see the power in AC circuit. In AC circuits, the voltage and current are changing their magnitude and polarities with reference to time. The electric power in the circuit at any instant is equal to product of the current and voltage across its terminals at the instant P equal to VI. The instantaneous power P equal to VI is equal to Vmax sin theta x, Imax sin theta minus theta, Vmax Imax sin theta minus pi. The average power, the mean power means average power, P equal to 1 divided by 2 pi. So integration of 0 to 2 pi Vmax Imax sin theta minus pi d pi. Vmax Imax cos pi divided by 2 equal to P equal to Vi cos pi, because this has the power factor, that's why we are using here cos pi. And V and I are RMS value of the voltage, current and to calculate power we should know the power factor of the load in AC circuit. The power factors are usually stated as leading or lagging to show the sign of the phase angle of current with respect to voltage. So this is the current lagging diagrams. This is current A, this is current B, this is voltage, and this is current B. The current B lags the voltage by 45 degree. So the vector points down and the right, see the below this diagram. The current leads by 45 degrees. It's happening 45 degrees ahead of voltage. So it points up and to the right. Since the peak currents are 1 ampere, the RMS currents are 0.707 amps. That's why we are using average value is equal to 0.07 amps. So this is the diagram. This is the leading time. This is the lagging time. 45 degree, 45 degree, 45 degree leading, 45 degree lagging. This is the average value 0.707. So current A, current B. This is the leading in 45 degree. This is lagging in 45 degree. So this is the example. The real power is 700 watt and this power angle pi between voltage and current is 46.6 degree. So the total power factor equal to 45.6 degree equal to 0.700. The apparent power 700 voltage watts divided by cos 45 by 6 degree equal to 1000 watt ampere. So this is the efficiency, this is the power input, this is the power output. The power output ratings of motor is usually expressed in a power unit cell on the horsepower HP. The relation between horsepower and watts is 1 HP is equal to 746 watts. The electric motor and the other system have an efficiency of operation P out divided by P in into 100%.